Kia ora koutou. I've got a couple of questions that you guys have sent me in for A-level stats tomorrow. So this first one is from Andrew S, and it's a question that looks like it might be a normal approximation to a binomial, but it's not. It's about the distribution of the sample mean, but it's set in the following context. So we're told that X is a random variable and it's got a binomial distribution, right? So N is 12 and P is 1/4. Then we're told that a random sample of 60 values of X is taken, and we have to find the probability that the sample mean is less than 2.8. So what am I working with here? Well, I've got X bar, which is the sample mean. Now we know that when N is bigger than 30, the sample mean is going to be roughly normally distributed, and it's going to have a mean, and it's going to have a variance, and that variance will be sigma squared on N. So let's look at what the mu is in here and what the sigma squared is. Well, the mu is what's the mean of my X variable. So let's go back to X. X is binomial and it's got N of 12 and P of 1/4. So the mean of X, E of X, is NP, which is 12 times 1/4. And the sigma squared in here is the variance, right? So the variance of X is NPQ, which works out to be, so 12 times 1/4 is 3. So NPQ is 3 times 3/4, which is 2.25. So what we can do now is we can get the distribution of the sample mean. So X bar is roughly normally distributed, very close to normally distributed, with a mean of 3. And a variance of sigma squared over N, which is 2.25 over 60. Right, now the question's not actually that hard. We're just asked to find the probability that the sample mean is less than 2.8. So we're working with a normal random variable. So the probability that X bar is less than 2.8 is equal to the probability that Z is less than this. So we standardize as usual, 2.8 minus 3 over, remember that it's always sigma over root n, so it's the square root of 2.25 on 60. And when you chuck all that in your calculator, you get the probability that Z is less than negative 1.033. Quickly sketching, this is the area that we want. So it's equal to that tail there, which is 1 minus phi of 1.033, which gives me 0.151. Okay, so there you go. So just a really nice last little bit of revision. Remember, the distribution of the sample mean will be normal as long as I've got a large enough sample. And the values that go into here will come from my original distribution. Thanks for watching. I've got a couple more questions that I'm going to YouTube over the next half hour or so. If you've got any last questions, please send them in. Try to get any emails into me within the next hour or so.